Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VGSOM IIT Kharagpur who is taking the course for you. We are in week 4 and we are discussing demand forecasting and pricing. So, in this particular video, I will talk about a special type of forecasting technique where the product is generally a durable product which you buy only once in a lifetime or probably once in a particular model at least if not in the lifetime, and then you the maximum possible market share is fixed. In this kind of a situation, what happens? So, we call it a technology adoption model where burst diffusion comes into the picture, and what I say that there are, for any product there is a product life cycle, and product life cycle, in the product life cycle if you have seen there are the product life cycle PLC curve, those in marketing 101 looks like this, the PLC curve looks like this, and if this is the thing, this is the sales at time t and this is time t. First the sales is low and then it picks up, then it reaches maturity and then declines. So, this is the part who are basically early adopters. Oh sorry, so these are innovators, then there will be early adopters. This part is probably so these are laggards. So, innovators, early adopters, late adopters and laggards, probably something like that. So, this is something that I try to look at, and this is same for more heavily same, I would not say exactly same for many technology products. Now, oftentimes we are interested to actually estimate this particular curve, how this particular curve will look like. And if you also see that if I try this as sales at time t, if I try to plot the cumulative cells looks like this. So, it goes up and then gets saturated at a certain point of time. So, if it goes up and gets saturated at a certain point of time, it might look like a S curve. So, this is how it looks like, basically it goes up and gets saturated at a certain point of time. So, this is the cumulative cells time t and that is how it looks like. So, this is something that we are trying to model, and then there was Professor Bass in I think 1960s when he has given this particular model, and he said that okay, so there are early adopters. What happens in the market? There are some, so it is also related to spreading of rumors, spreading of virus infections, actually happening of a viral message or probably creating a revolution. All of these things are related to this kind of a model, where there has to be a significant mass accumulated at the starting point. Only when that significant mass gets accumulated, it will actually reach the inflection point and then it will go up. If it does not get that significant mass at the starting point, then it will not actually reach the highest level. So, that is why maximum amount of technology products fail because they fail early, and the early failure occurs because the significant mass is not getting generated, significant amount of demand is not getting generated at the starting point of their life. So, that is something which is common, and you will see that epidemic is not very common, viral epidemic is not very common. It happens, but if you can actually take care of in the starting point in the first 100, 200, 1000 patients, if you can limit it within that limit, then you are safe, you can survive. But if it goes out of the hand, if the significant mass is getting generated in terms of number of patients at the starting point, then it will reach a epidemic point of view. So, something like that is this particular model, where Bass told that let us say the accumulation, the extra sales Ft, if the total sales possible is 1, the 100%, then the percentage sales happening at time period t will actually depend on two things. There is some innovators, P innovators, and then there are Q adopters. So, P is called coefficient of innovation and Q is called coefficient of adoption. So, some guys who are innovators. So, there will be always some people who will actually who will actually be there in a mass, in a huge mass, who will be coming in touch with this particular technology and buy. Let us say p% of the overall population are innovators. What is the innovators mean? Innovators means whenever they come in contact with a particular technology, they purchases the technology, or whenever they come in contact with a particular virus, they gets affected by the virus. Whenever they comes contact with a particular, let us say, viral message, they share the viral message. So, these are the guys who are innovators. So, at time period t, how many persons are left? At time period t, ft persons, ft, the small ft persons are actually who are going to adopt this particular product at time period t. Fair enough. Then, if the t is very small, then capital Ft is basically summation 0 to t or summation or integration Ft dt, or it is the, in other words, in normal language, it is the total cumulative number of people, cumulative cells, the up to time t. So, up to time t total cells that has happened, or total number of people who has got adopted, is actually told by capital F t. Now, if capital F t number of people has already bought this particular product up to time period t, then how many people are left? Assuming the total is 1 minus F t people are left, this many people are left, and out of this many people, p percentage, p proportion of people will actually come in contact and purchase each every time period. So, p into 1 minus F t, this many people purchases at this time period, adopts on their own. Now, the rest of the people does not adopt on their own, they adopt based on whether other people have adopted or not. So, they actually are friends of the already people who have adopted. So, what happens is this capital F t people who have already adopted, they go and talk with others, the word of mouth, and because of this word of mouth, there are some people gets affected. How many, which people are there? Q into F t, this proportion number of people, means the more the adoption happens, the more the adoption happens, the more is the chances of word of mouth. No. So, if more number of people have actually experienced the product, then the word of mouth will happen more. So, this is the overall word of mouth, this part is the overall word of mouth. Now, this proportion of people come from where? The same, the rest of the guys, they will come from the rest of the people. No, they will not come from somewhere else. So, this is my total rest of the people. This is my total rest of the people. Now, out of this rest of the people, p proportion comes on their own, and q into F t proportion comes by word of mouth. They do not come on their own, they come by word of mouth. So, as F t goes up, as already accumulated cells goes up, as more adoption, number of people who have already adopted, let us say WhatsApp. WhatsApp, how many people will actually adopt? So, let us say today is 2020 and there will be, how many people will adopt in, let us say February 2020, how many people will adopt? So, let us say if there are around, I do not know, 10 million or 100 million customers possible who have internet access, they are possible 100 million customers, and out of them have 50 million has already adopted, then the rest is 50 million. So, as this rest of 50 million is higher, the chances of adoption is higher. As this shrinks, this rest of 50 million shrinks, the number of people who will adopt at a time period will also shrink. If instead of 50 million, if it was 5 million, the rest of the people, if by chance instead of 50 million, if it was 5 million, then the number of people who will adopt in February 2020 will also be smaller in the second case. So, how many people will adopt in the current time period will depend on how many people is left aside till now, who have not adopted till now. So, that is this part is that, and how many people will adopt in the current time period will depend on some amount which is actually the innovators who depend on nobody, which is the P, and some amount which depends on the already adopted people. If the already adopted people is 25 million versus the already adopted people is 5 million, then the 25 million guy will have a higher word of mouth than the 5 million guy. So, that part is actually taken care of this point, where we are talking about the imitation part. So, this is the P is called coefficient of innovation, and this Q is called coefficient of imitation. So, and these two has huge meaning. So, by saying that, what I am trying to say is that the currently the I would say just 1 minute. So, currently the what is the function then? The function is f t by 1 minus capital F t. This is actually the function of Bars diffusion model is P plus Q of capital F t. Okay. Now, if you actually try to solve this is a differential equation, and if you try to solve this, and what is sales at time period t? If total number of market share is m, the total market number of revenue that you create, m into small f t is the total sales that can happen at time period t, and the functional formula for this is, if you solve that, you will find m p plus q square by p, this is the part, into e to the power minus p plus q t, and this function I do not remember, I am just writing it from a note that I have. So, it is difficult to remember. 1 plus, you can just Google it up, e minus p plus q t square of that. So, you can just Google it up, I am not saying that you have to. So, but I have actually copied it, I have kept a note and I have written it there. This is the function that is there. So, this p and q in general is a cumbersome formula, it has no purpose, but there are some things where it helps. So, this is the sales function. So, if we will use this particular sales function later. So, we have to remember this is the sales function. Do not remember this, we have to note it down, so that we can use it later. That is number 1. What extra? So, you will see that there is a peak point when the sales is peak. That peak sales point is called, the function is ln q log of q minus ln p log of p by p plus q. And at this time period, the number of products that are sold. So, f t is basically 1 by 4 q and p plus q square. So, you will see that at the highest time period, when the more is the innovation and imitation, the higher you will reach, and the more is the imitation in comparison to innovation, it will come down. So, that is something that we get. And if I want to find out the cumulative cells, if I try to find out the cumulative cells, that was individual cells, this was individual cells. If I try to find out the cumulative cells, the formula is, so f t, the formula is basically, and S cumulative cells CST is nothing but m into f t, capital F t, and capital F t's formula is basically 1 minus e to the power p plus q t divided by 1 plus q by p e to the power minus p plus q t. So, something like that is the formula, and we will use these formulas to estimate the effect of the effect of innovation and imitation in case of a technology product. So, how do I do that? So, let us say I have a data set, simple data set. This is the data set, the various times, and you will see that 100 is the maximum possible achievable sales, and I have 12% of the maximum possible has been achieved in 2001, 17% in 2002, this is cumulative, 20% is 3, 24% in 4, and etc., etc. That is the value that I got. Now, let us say if I say that okay, the cumulative value P is 1 and Q is also 1, then what is the cumulative value? The cumulative, so this is my predicted, the predicted cumulative value is, the formula is written here, 1 minus, so is equal to, just check what I am writing, 1 minus exponential of what? Exponential of something. What will I write in this something? In this something I will write something into the t, the t is this, and what is this? This is P plus Q. So, this plus this, and H2 and H3 I have to put a F4. So, carefully see what did I write, the equations. I am just writing the equation of this equation, basically I am writing this equation properly. So, you have to find out that whether I am writing correctly, and then divided by 1 plus what is here, an exponential of something here. What is here? I will write Q by P. So, Q by P means this divided by H2. H2 is, and I will put a F4 signs here, F4 here and F4 here, and exponential whatever I wrote inside this one will come up here again. So, the same P plus Q into T, I will put it here and then put a negative sign in front of it. So, if I just run this, I think I have wrote this one will be negative here. I think I have not run it correctly. So, this is something is the percentage. So, this should be, if I am not wrong, this should be minus also, just check, I have forgot. So, this is something that is the formula that we get, and if I try to so this is something, and then this is in proportion term. So, this into 100 is the maximum possible thing. So, this is what I am getting, say 76 to 100. I will reduce it a little bit. Let us say this is 0.5 and this is also 0.5. Now, if I just try to plot it, if you see that if I try to plot this particular curve, this curve comes up to be as almost a S curve that I just told you. Let us say if I further reduce it, let us say 0.25 and 0.5, then try to plot it, it comes up to be S curve. So, simple good looking S curve. But these values and these values are different, because the actual PQ value and the one that I started with will be different. So, how much is the error? The error is basically nothing but the 12 minus this square. So, similar to previous one, I am getting my error square. So, I can say square error SQER, and then what is RMSE? RMSE is nothing but square root of average of this particular column, and I have to somehow minimize this by changing what? By changing P and Q, that is the one that I do not know, and P and Q. Now, remember P and Q has to be positive, it cannot be negative. I cannot have a negative proportion. So, I will solve this, and it gives me, okay, so P is 0, P cannot be 0 as well. So, that is something that I have to also check. So, sorry, I forgot that. So, I have to check that it cannot be 0. So, solve and add that, okay, these guys has to be greater than equal to 0, add. Okay. So, now if I have this one as my constraint, now if I try to solve, oh, it is still coming up to be 0, just 1 minute, I have done something wrong. So, it might be the case that, okay, P cannot be 0, because if P is 0, then this one comes to be infinite. So, what did I do? Okay, I wrote greater than equal to, that is something that I did wrong. So, this is not greater than equal to, change it and make it, okay, so greater than equal to some very small value, 0.001. Okay. Now solve it. Okay, so I have to change 0.25, 0.5 and in the solver I change it to 0.001, solve it and now I am getting some value. Fair enough. So, this is the predicted, this is the actual and I am RMSE is much lower and these are the cases that I am getting. So, initially I am not getting good results, but as I go ahead I getting good, pretty much very close 89, 90, 87, 81 and so on. The primary 2-3 values are not very good. So, this is the table. So, if I just try to plot these two curves, see these are very close curves actually what I am getting and that is how. Now, if I know that okay, if I have to know that at what point I will reach 99%, when I will over more or less get everything, I will just simply use this one and probably drag it up probably up to 65th time period, I do not know. So, 12, 13 and then I will drag it up to 65 time period and if I just double click on this, it will give me okay. So, you were reaching 99 at 21st time period. So, another probably 8 time periods and you will reach your maximum possible thing. Now, why this is important? Why will I use it? Now, if by chance I know that my PQ is like this at this point of time at 32, then I will know that at what point I will reach the maturity. And if I know that at what time period I will reach the maturity, in how many days I will reach the maturity, I can pre-plan. If you remember like iPhone 1 and iPhone 1, iPhone 2, so they keep on innovating. So, they try to create a curve, cells curve which looks like this. So, their PLC curve is like this, it goes up, reaches the maturity and then another curve comes up. From here itself, another curve comes up and goes. So, they do not let it come down, they come up with a newer products and etc. So, this is something that is important. If I when I standing here, if I know that okay, I am reaching maturity or not, I at all if I am reaching maturity or not, then this particular thing is okay. Now, you will also see that this p, if with by chance if the p value is very low, by chance if the p value is let us say, I am just giving an example, by chance this p value is 0.0001, then how does the curve look like? Just try to plot this curve when the p value is very low. So, the p value is very low, it will reach it initially it will be absolutely 0, nobody will buy it initially. So, if nobody buys it and then even only after 30 months or 30 years somebody buys it, this is the yearly data. So, 30 years somebody buys it, then actually it fails, it will fail into 3. So, that is something that is very important to understand, that the p has to be higher. So, p has to be at least 0.02 to get something, to reach up to a 10th level or something like that. So, that percentage should be there in your p, which is the coefficient of innovation, and then coefficient of adoption can be something that is also very important, but this is something that is very important. If it is lower, then your product does not reach the maturity level, it will actually die after second time period, third time period, at max 10th time period it will die. So, that is something that will keep into account. So, that is all for sales forecasting, we call it burst diffusion model, and later point of time people have actually included much other things. So, for example, now I have some error, I can also find out how this error which is not related to diffusion, which is related to something else. So, I can find out a predictive model where this error is predicted by the price and sales and advertisement expenditure and etc. So, how much price I have given on that particular month, if or a particular year, if the price on that particular year was higher, the demand will be coming down. So, again all the rest of the part which is non time series part can be explained by just putting a regression equation with this error. Here it is square error, I have to square root it up. So, with the error component and all other x variables that you have, you try to create a regression equation. So, that is all we have about forecasting. We will go on and meet you in the next week, and we will do how to use this forecasting. So, how to use this demand function in various pricing problems, we will talk about that in week 5. Thank you very much for being with me.